Let's work through question 36 from chapter 9. So we need to consider the following test. Our null hypothesis is p is greater than or equal to 0.75, and our alternative hypothesis is p is less than 0.75. So a sample of 300 items was selected. Compute the p-value and state your conclusion for each of the following results. We're going to use 0.05 as our alpha in this problem. So we have part A, where p bar is 0.68, and part B, where p bar is 0.72. So let's work on part A right now. So in order to find a p-value, we first need to find a test statistic. So in order to find a test statistic, we need to prove that we can use a z-score. So we can find our proofs for proportions and find that we are able to prove that we can use a z-score in this problem. So our z-score formula is p bar minus p null all over the square root of p null times 1 minus p null over n. So p bar is just going to be our 0.68, like you can see over on the left side of the screen. P null is going to be 0.75, and our n is 300. So we can plug all of that into our z-score formula, and we'll find that that simplifies down into negative 0.07 over 0.025. That then becomes negative 2.80. So that negative 2.80 is our test statistic, and we are going to use that to now find our p-value. So now we can draw the bell curve, and we can put our test statistic on the bell curve. And then what we need to do is we need to take a look at our alternative hypothesis that we have over on the right side of the screen. The sign in that alternative hypothesis is pointing to the left. That means it's a left-tailed test. So we need to find the area to the left of this test statistic. So now we'll take a look in our z-score table at negative 2.80, and we find that the area to the left of that z-score is 0.0026. That 0.0026 is your p-value. So now we can use this p-value to figure out a conclusion. So we have this rule that we'll follow, where if the p-value is less than or equal to alpha, we're going to reject the null hypothesis. Well, we said our p-value is 0.0026. We were told at the start of the problem that alpha is 0.05. So our p-value is less than or equal to alpha, so our conclusion is that we will reject the null hypothesis. Now we're going to change it up a bit and say our p bar is 0.72. We're still going to use this same z-score formula. And the only piece that's going to change from the first time that we use this is our p bar. So we plug in 0.72 minus 0.75 over the square root of 0.75 times 1 minus 0.75 divided by 300. That simplifies down into negative 0.03 over 0.025. And you get a test statistic of negative 1.20. So again, we're going to use this z-score, this test statistic, to now find our p-value. So we draw the bell curve, and we put our z-score of negative 1.20 on this bell curve. We'll now take a look at the alternative hypothesis. Notice the sign is pointed to the left, meaning it's a left-tailed test. So we need to find the area to the left of that z-score. So now we'll look in our z-score table and find the area to the left of negative 1.20, which comes out as 0.1151. And that area to the left, that 0.1151, that is your p-value. So again, our rule is if the p-value is less than or equal to alpha, we reject the null hypothesis. Well, we just said our p-value is that 0.1151. Our alpha is still the same as what they said at the start of the problem. It's 0.05. But now our p-value is greater than our alpha. So the conclusion that we're going to make here is do not reject the null hypothesis.